Hello everybody, it's Dumplet here, and here's an item on geometry. Credits to my friend Mark Justin Villaferte for giving me this item. Now he is an incoming grade 9 student who's very talented in math. So without further ado, let us dive into the question. Now let triangle ABC be an isosceles triangle with AB equals AC and angle BAC equals 100 degrees. A point P inside the triangle ABC satisfies that angle CBP equals 35 degrees and angle PCB equals 30 degrees. Find the measure in degrees of angle BAP. Now we have the figure below for reference. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now as the bolded text here suggests, there are a lot of motivations to do with this item. Now, the first thing I did, and then again, all of us may have different solutions, but this is the way that I did, and this is the way that I will be sharing. Now, first thing I did was to create auxiliaries. In fact, I created an equilateral triangle. Now, I selected point D here such that triangle ACD here would be equilateral. Now, the reason being is because I will be able to form another pair of congruent sides. Sides AB and AD. Now AB equals AC by the given, and now AC will be equal to AD because it's equilateral. So I will have another triangle here, triangle ABD, which would be our next target. Since triangle ABD is an isosceles triangle, it will make sense for us to draw segment BD. Now, if I draw segment BD, note how it will intersect with segment PC over here. So let us do the following. Let T be the intersection of segments BD and PC. Now, this will be the result. And we have a particularly interesting thing that we can try to see. ATM, well, in the figure, it seems to be collinear. Now, let's try to prove that it is indeed collinear. So we're trying to make observations along the way. So aside from the obvious givens, let us find things we can discover from the givens. Now we know that angle PBC equals 35 degrees, hence we have this 5 degrees over here, and I know that PCB is 30 degrees, hence a 10-degree angle here. Now, since I drew BD and I know that triangle ABD is isosceles, I know that the vertex angle would be angle A here, which should be 100, which is in the given, plus a 60-degree here from the equilateral triangle, giving it a total of 160 degrees. Since the vertex angle is 160 degrees, we know that the base angles should be 10 degrees each. So this will be 10. And this would be 10. And why can we split this into 5, 5? That's because if we go back to this figure, this angle is 5 degrees. So to make 10, the other also must be 5. Now, this is particularly interesting since we have another concern here. Segment BP was interesting now because segment BP here bisects angle ABT. So for now, let's just remember that. Going back, we want to prove that ATM is collinear. Now, we can do that easily because since we have the 5 degrees here, angle DBC over here, or angle TBC over here, would be 30 degrees. And this is coincidentally equal to angle PCB, or also known as TCB. Now, TBC is getting interesting now, so triangle TBC is also equilateral. It's also isosceles. Now, since we know that AM here, well, we let M to be the midpoint of BC. AM is an altitude. Since triangle ABC is isosceles with a vertex angle at A, we know that AM must be perpendicular to BC. Now, since TBC is also isosceles now, we know that TM would also be an altitude, and therefore M would have to be the midpoint. So ATM are indeed collinear. So we have AM, BD, and PC, these three segments being concurrent at point T. Now, the next thing of concern is that since we have a 30-degree angle here, we know that this angle would have a degree of a measure of 10 degrees. Now, this 10 degrees goes very, very well with this 10 degrees over here. Now, this 10 degrees came from this angle being one of the base angles of isosceles triangle ABD with a vertex angle of 160. Now, since both of these are 10, and look how angle ADT and angle ACT intercept the same segment, AT. Now, this will give us a clue that ATCD is indeed cyclic. Now, in fact, I'm going to draw a figure. If we draw a circle, it will pass through all 4 points. And this is a consequence of cyclic quadrilaterals. So, since angle ADC equals angle ACT, so angle ADT is equal to angle ACT, we know that ATCD is a cyclic quadrilateral. We can extract more information on angles related to these 4 vertices. So since angle DAC is since angle DAC is 60 because this triangle ADC is equilateral, and since quadrilateral ATCD here is cyclic, we know that angle DTC here would also be 60 degrees since they subtend equal arcs. The same arc. So arc DC over here. Now, next thing to be looked into is that since we have a right angle here at M, we know that TMC here is a right triangle. Now, it's particularly nice that the 30-degree angle here, angle TCM or angle TCB here has a measure of 30 degrees, gives us angle MTC to be the complement of 30 degrees, which is 60 degrees. This is nice because TC bisects MTD now, and we can have a simple use of the vertical angle theorem to show that this angle, so angle ATP, is equal to this angle, angle PTB. So in fact, TP is an angle bisector of angle ATB. Now, P here would be interesting now, since TP and BP are angle bisectors of angles B and angles B and T in triangle ABT, which means that point P is an intersection of 2 interior angle bisectors of triangle ABT. Now, this is nice because we can get P. That we know what P is. P must be the incenter of triangle ABT, since P is an intersection of 2 interior angle bisectors of this triangle. So we know that P must be an incenter. Now, we're almost done with the item. All we have to do is to note that angle BAP, well, since P is the incenter, we know that AP should also become an angle bisector then. So we know that BAP will be simply equal to 1/2 of angle BAT. Now, we know what BAT is because it's 1/2 of BAC. Since, well, AM over here, it's an altitude of this isosceles triangle here. Well, it's also an angle bisector here, so BAC is 100, so AM bisects angle BAC. So angle BAT over here, this angle over here, should give us 50, which is 100 over 2. So consequently, angle BAP, which is 1/2 of angle BAT, so this angle over here, this would be 50 over 2, and this will give us 25. So this will be our final answer. So there's a lot of things to consider here. I drew quite a number of auxiliary lines and shapes, and yeah, hopefully you guys learned something new from this video. Hopefully you got some insight and some motivations to future geometry items you may encounter, and Dumplet will see you in the next video. Bye bye.